Okay, grade 10s. So what we're going to start now is our second unit in this course, which is chemistry. So this is going to be a fairly large unit. It will probably encompass most of the rest of the year, just because it's very important to understand the chemistry. Because as we go into next year, if you decide to go into chemistry, biology, or physics, it's important to know at least some background in chemistry. So let's go through this. We're going to do kind of a little bit of a recap of grade 9 today. So both lessons are going to be kind of recapping some of the material that we've gone in grade 9, but some very essential material in order to be able to understand what we're going to go into in grade 10. Okay, so just recapping grade 9 about atoms. Okay, so everything in the world, with the exception of energy, is made up of these little tiny spheres, which we call atoms. Okay, so if you look at anything, you look at a table, you look at a book, you look at your computer. Okay, if you could get close enough in a microscope, you'd see that everything that it's made up of is just these really, really tiny spheres. Okay, so if you look at the picture that I have kind of here in the top right, okay, this is kind of the idea that you can look at any object, and if you look at it close enough, all it is going to be all these little tiny spheres. Okay, and all those little spheres are what we call atoms. Okay. So atoms are what the building blocks of everything. You can kind of think of them almost as Legos. You can build a bunch of different things with Legos. Atoms are the same kind of thing. You can build a bunch of different things with atoms, including you. Okay, you're made up of a bunch of little tiny spheres. Now, atoms come in different sizes, colors, shapes, abilities, and weaknesses. So some atoms are really, really strong. Some atoms are weaker. Some atoms are reactive. Some are yellow. Some are green. Okay, so there's a big variety in atoms. Now, if you look here at the bottom right, okay, the differences between, like, say, solids, like a piece of ice or, say, a table or a book or even you, okay, why you're solid is because all of your little spheres are very close together. Okay, so kind of looking at this picture right here. When all the spheres are really, really close together, that makes solids. And then as we go to something like a liquid, why it's a liquid is just because the spheres are a little bit more spread out. Okay, so it'd be very similar to like water. Okay, why water, the difference between, say, water and ice is the distance between the little spheres. Okay, and then the last one that we have is gases. So anytime you have a gas, like say oxygen gas, why it's a gas is because the spheres are so spread out. Okay, they're not very close together, and then we can walk through them. We can, as we walk, we're kind of going right through the spheres, and that's why we really don't feel too much as we walk through outside. We can feel a little bit of wind resistance, and when you feel wind, that's what's happening, is these little spheres are hitting you, and that's what you're feeling in wind. But it's not as strong as, say, if water was hitting you, because if water was hitting you, look how many more spheres would be hitting you. And then if, say, like something like solid, like a book or someone's hand hits you, okay? Why it hurts so much more is because so many more spheres have hit you. It's much closer together. Now, atoms can exist on their own, or they can attach to other atoms and make what we call compounds. Okay, so those are what atoms are. Now, what are elements? Well, elements are all the different kinds of atoms, or the building blocks available to create objects. Just like in Lego, if you kind of think of atoms and Legos being very similar because they're both building blocks, you have yellow Legos and you have green Legos and you have big Legos and small Legos. Elements are all those different kinds. It's kind of like your entire Lego kit. It's all the different types of atoms that you can have. Okay, you can have, some examples are like hydrogen. So you can have hydrogen atoms, or carbon atoms, or oxygen atoms, or nitrogen atoms, or calcium atoms, or phosphorus atoms. Okay? And all these different types are called elements. Okay? And elements are really just all the options for atoms. Okay? There are about 118 different types of atoms. Okay? So there's 118 different building blocks that you can build things out of. So everything is really just made up of 118 different things, different combinations. Now, each atom of a particular element is different than the atom of another element. So if we look at, say, copper, okay, so that's the element is copper, and then those are the atoms inside that I'm pointing to. Those are copper atoms. Okay? Carbon atoms look slightly different, okay? And that's why something like charcoal looks different than copper. Their atoms are slightly different. And then we look at something like helium, okay? Helium and gas, really, really spread out. The atoms look even different. They're much smaller. Now, how do we figure out where all these atoms are? Well, all the atoms are listed on the periodic table. So what is the periodic table? So I will be posting kind of a copy of this. So this is something that you'll definitely use quite a bit for the rest of the year. It's called the periodic table. You should be familiar with it from grade 9. Okay? And it organizes the different options for atoms or elements. So basically it says these are all the building blocks, okay, that you can potentially have. So most elements or options for elements are metals. Okay, so most of our building blocks are metals, and I'm going to highlight kind of all the metals here. Okay, all in this kind of light blue color. So all of these are metals. You can see most of the elements are metals. Okay, and then only a small number, which I'll kind of highlight here in red, are non-metals. So we've got hydrogen that's kind of by itself over there, but all the rest of the non-metals are all over here in green. Okay. What we have in orange is not something we talk about too much in, at least in grade 10. They're called metalloids. They're kind of a little bit metallic, a little bit non-metal. So it's this kind of this in between. So non-metals would be things like cotton, wood, plastic, and then metals would be, you know, what you traditionally think of as a metal. Okay. All right. So there's just a bigger version of the periodic table, right, and all the different types of elements. Okay, so just kind of finishing up, it's the difference between atoms and elements. So atoms come in different sizes, colors, shapes, abilities, and weaknesses. The options for atoms are elements. Okay, that's what we went over. So if we look at some different elements here, so this is lithium, right? So this is the element lithium, right here. And this would be like kind of what it would be made up. So if you grabbed a piece of metal, of lithium metal, and you went really, really close, it'd be made up of all these little tiny spheres. Okay? Now, if you get even closer, and you say, well, what does each little sphere look like? This is the construction of an atom. We'll be talking about this coming up, but you should remember this from grade 9. You know, you have the nucleus, protons, neutrons, and then electrons going around the outside. Okay. Well, something like sulfur is a little bit different. It looks obviously different than lithium. It's non-metal, okay, but it's still going to be a sphere. Okay, and if you look at it really, really close up, it looks much different than lithium. Okay, there's a lot more what we call electrons on it. There's a lot more protons. And that's why it looks different. Okay, over here we have fluorine gas. Okay, so fluorine gas again would just be made up of a bunch of spheres. Okay, and if you get those spheres really, really close, and these are called atoms again, these spheres. Okay, that's what it would look like. Okay, and again, it's all slightly different. So why things are different sizes and different colors and different shapes, and they have different abilities and weaknesses, all comes down to their structure and the fact that the number of electrons, the number of rings, and really kind of going down to the atomic structure is the reason why they have all these differences. Okay, so the next thing that we're going to get into is once we know about all these different building blocks, so once we've identified all the different building blocks, what chemists spent a tremendous amount of time doing is saying, okay, well, let's just take this building block right here and let's investigate everything about it. I want to know what its boiling point is, what its abilities are. Is it a solid? Is it a gas? Is it a liquid? When does it turn into the different states? What are some of the weaknesses of this building block? What are some of the strengths of it? And then they analyzed everything, and then they would go to the next one and say, okay, we're done with copper. Let's go to, say, chromium. And let's analyze everything about chromium. I want to know, what is it good at? What is it bad at? Is it really good at conducting electricity? Is it bad at conducting electricity? Does it melt at a low temperature or a high temperature? So they want to know all these different aspects about them. And the reason for that is because a big job of chemists is to do material design or picking the materials. So once we know everything about all these different elements, we can say, oh, you need to make a faucet. I know the perfect building block for that. It is nickel. Right? And we're going to use nickel. You don't want to use iron for that. It's not going to work. We don't want to use magnesium for that. Titanium's too expensive. So we're going to use nickel. Right? Or you want to make a basketball. Well, I can't obviously use nickel for that. I'm going to have to use a combination of carbon, hydrogen, and oxygen in order to make that basketball. Right? So chemists have really kind of broken down into saying, okay, what are the advantages of different elements, the strengths and their weaknesses? Okay, again, even in, say, car design. Okay, if you want to make a really, really light car, say like out of carbon fiber, the only reason they were able to do that is they investigated carbon and said, wow, this is an amazing element that has a lot of strength, but it's also really, really light, unlike metals, who have a lot of strength but aren't very light. So they're basically going through and figuring out what we call chemical and physical properties. Okay, thanks, guys.